Hi, sir.
Hello, Amy. How are you doing?
I'm good, thank you. How are you?
Great. Thanks a lot. Yes, so we're done differentiation. How do you feel after doing differentiation?
Oh, I actually feel quite very confident because obviously, with like you said before, every time we go through these lectures, you always have these exam style questions throughout, and so that obviously helps me get comfortable with doing questions from my book. And because you cover like such a variety, I am used to the different types of questions that could come up, and I don't actually get surprised that much of like the questions. So yeah,
That's
it's
great.
been
So I thought I can share this strategy with some of my students who'd like to learn from me,
good.
because I found that this process of teaching you online. You are in England, UK, and I'm in here, Toronto, Canada. Was very effective. And we did complete the whole curriculum on calculus differentiation part in very few lectures. And since now you're saying that you could actually do most of the questions without any problems, I think it is a very effective way. So I thought let's share this with some of our viewers, and if they are interested, they can learn from me also, right? So let's go through this process and see what really happened, right? So this is something which I prepared based on what we went through. So basically, when you contacted me at that time, I thought, um, you know, the most difficult topic for you was calculus, right?
Yeah.
So I thought, let me get you prepared for calculus, and then we'll straight jump to one of the major topics, and then we can get back to simpler questions or simpler topics, right? So
Right.
it was a challenging thing to think about. How surprised were you about this decision of mine?
Yeah, no, I was quite surprised because this obviously, I felt like I didn't have the base in order to start calculus, but because you started it off knowing where my ability was, you build on whatever I had, which was not that much. And then, like, you did the whole pre calculus thing to like prep me up for the main, like, things like differentiation and obviously after that integration. So I definitely felt like even though it was a complete brand new topic that I had no base of whatsoever, you managed to get me to understand the whole thing, so many different concepts and so many other topics that weren't in my curriculum for year 12, but obviously would come later on in year 13. So it's good to get used to and know about those concepts earlier on.
That's true. So from my experience of the last 15 years, I've noticed that, when somebody is preparing for an exam, they're always looking at hard questions. And if you look
Mhm.
at GCSE level A questions, the most difficult ones are from the calculus part, right? So, so the idea here is anybody who comes to me to learn, uh, they expect that at the end of our lesson or the classes, they're in a position to solve all the questions which are there at the end, right? So my idea is that why not prepare a student so that the student knows that there is the ability of doing those questions very easily, and so take off that pressure away. So once that pressure is off, learning becomes so relaxing and beautiful.
Yeah.
That's my thing. And therefore, I just saw your curriculum. For year 12, I was surprised that there are only very few topics for differentiation. And I thought, therefore, that we could jump into that with slide preparation, which we call
Mhm.
pre-calculus. Even otherwise, whenever you do calculus, you have to do brushing up of some concepts. Otherwise,
Definitely.
right? So I took a few interesting topics which could be very useful for you, especially polynomials, rational functions, to move forward. So what I actually looked into were these topics which we wanted to cover for the calculus differentiation part, right? So I listed them all here, which starts with gradient, finding derivatives, differentiation, and then differentiation of many functions, gradients, tangents, and normals,
Mhm.
decreasing, increasing, second order derivatives, stationary points, sketching, and real life situations and exam practice. So, in short, that was the curriculum which you're supposed to do for year 12.
Right.
Uh, but when I really analyzed it, I found that it'd be very difficult to teach you only these topics, and therefore I introduced many more. which will be required in your year 13. And definitely when you appear for GCSE level 8, you'll be well prepared, right? So
Mhm.
one of the major topics which I introduced was limits, right? So without limits, we cannot really jump into calculus and differentiation for that matter. So, and then another thing which I noticed was that you had a very simple statement there, differentiating x to the power of n. Well, that's a polynomial function, probably one of the easiest one to do the derivatives. So I kind of ignored it because, when you do differentiation, that is kind of comes obviously, right?
Yeah.
So what I did was introduce you to many functions which were not polynomial, but that function which you expect in examination. When we're learning a concept, why not have a broader base? Right? That was the whole idea, and I think that gives you a lot of confidence. And so the questions in your book were so easy for you to solve, right?
That's true.
So
Yeah.
that's the whole idea. So I actually designed a new curriculum for you, which could match for both year 12 and year 13, and then you could actually solve any GCSE level A test paper, right? So let's see what we did. Okay, so here is the first slide which I want to share with you. What was your reaction when you saw this on limits? The very first question.
Yeah, so this was so when I first started with you, the reason I came to you was because of exponentials and log. So obviously the seeing exponentials in differentiation, I immediately got a bit like, oh no. For starters, I was like, how did you get that topic into this topic? Because you've intertwined them so well. But this question, I felt like it clearly showed me exactly what limits were and understanding the whole concept of limits just from this question, because it's very clear, like from the table showing the left side and the right side and how you come to the same value. And because in log, I knew that the value of is 2.7 184. I that can, like, I made that connection of how, oh, this is how you get to it, like that those two links were made, so that made it easier for me to understand that. So yeah.
As you said, Emmy, you actually dropped into my YouTube channel because of exponential and logarithmic functions. And that's a very strong topic on my YouTube channel, and many people come looking for those kinds of videos. Now, so when I thought about your introduction to calculus, and definitely this was not there in your book, I wanted to reconnect with you with the same topic where we started with, right? Remember, we did exponential logarithmic functions within a week, right?
Yeah.
So I thought it's a good idea to give you more knowledge about E itself, which is one of the most important thing in our calculus or in algebra or mathematics, whatever, right? So we started with limits, which was a new thing for you, of course, and then we derived the value of E, approximate value of E, straight away, and that was our introduction to the calculus, right? And the concept of limits, and from there we found what is the definition of tangents and gradients specifically, correct?
Right.
So when we talked about gradients, then I shared with you another very important question. What do you have to say about this particular question?
Oh, so I actually remember doing this one with you. And when I first did it, I think the first point to initially make is read the question carefully. As much as like trivial as that sounds, it's important to do so because, like I did when doing this question, I assumed the point they were talking about, where it says cuts the y-axis at 0 minus 11. I assumed that was on the curve. But as the graph clearly shows, it is an external point. So that means that there would be two tangents. So yeah, so that's also important. Looking out for these key hints and things in the question. If they say tangents, then knowing there will be multiple of them. Just bear that in mind when doing the question, because obviously that would affect the answer.
That is so true.
Yeah.
So this is the type of question which actually throws you off in examination. And so not only we learn that the point necessarily is not on the curve, it could be an external point, right? That's kind of important. We also learn or consolidated our learning about the limits. How do we find the gradient at a point, or if the point is outside, or gradient for any point on the function using the concept of limits. So we consolidated on that concept. Also, we utilized our slope or gradient formula, which is change in y over change in x, and combine the two to get the solution of this particular question. And therefore, I feel this is a very important question from learning point of view.
Yeah.
And then, yeah, so this was excellent actually, and we really enjoyed this process. And you learned quite a bit about it from there. And then the concept of one-side limits. I introduced you to the concept of one-side limits. As such, limits was a new topic for you, and then
Yeah.
you're talking about one-side limits. What do you have to say about that?
Yeah, so I did find it quite tricky because it's not in my curriculum, but Mr. Kumar obviously led me from the beginning on the basics, obviously. So as you can see, small minus on the top and the plus on the thing means left side, and then the plus means the right side. So simple, like basic concepts like that, just so that I'm aware of when it does come in year 13, I would be aware of what limits are, what it looks like, and when it's on a graph, knowing the different, because it's like applications, you can find curves from the limits. And we've talked about the jump discontinuity and the vertical asymptotes. And like when approaching from the left or the right side, it's trying to get or approach a value and get as close to the value as possible. So knowing that is very helpful.
Okay. And from here, actually, we learned a lot of concepts. One concept about the continuity, right? We said, well, if the limit exists and the value of the function is same as that of the limit, then the function is continuous. The other was, if the limit exists, but the value is different, then it's a whole, right? And
Right.
then if the value does not match up, that means the limit does not exist, but the limits from one side exist. In that case, it is a jump discontinuity. So again, it was going back to your one of your chapters on functions, which consolidates and helps you understand those things better. So when we are introducing you to a topic, it is good to have a good connectivity, right?
Yeah.
So then here is another question on limits, which I thought will give us very good practice. So I took up this particular thing, and here the questions in limits are really very interesting and sometimes difficult to do. Here we learned a new concept, and that was when you have to rationalize, then normally students think that you have to rationalize either a denominator or the numerator. But the examination type questions may involve rationalization of
Oh,
both, which
yeah.
was there with this particular question, right?
Right. Yeah.
So that was good. And then we also introduced you to the other types of functions, which are trigonometric functions. We really didn't go into details. We left it for year 13, but
Mhm.
a small introduction is always better to understand.
Yeah, I love that page because of all the variety that you've got from question like 1 to, was it 13? Yeah, 1 to,
That's true.
yeah, like you can see absolute value, you can see the 2 to the minus 1 negative values, not just all positive or not just all just simple quadratics. You've got the rational, you've got the trig, you've got so many aspects of the concepts that I've learned like previously. So seeing it intertwined into this one is just so useful to see.
Correct. So that's what I meant when I saw a curriculum that is only polynomial x to the power of n mentioned there. How
Yeah.
in the GCSE paper, I saw so many of the functions being there in the examination, right? So why not introduce them right in the very beginning? And it's such a complicated function here. And not only that, the important concept which we learned was limit approaching infinity. So that is again a very important concept which you have been doing so many times earlier, but not really realizing how to figure it out, right?
That's
Uh,
true.
it gives you horizontal asymptote, right? So if you want to find horizontal asymptote, you're looking at the limit when it is approaching infinitely large values. Even in sequences and series, when we want to do sum of some particular series, we're looking at this limit, right? Whether it converges or not converges. And therefore, it's a very important concept to be introduced right there. So that was a beginning or kind of, you can say, pre-calculus for you, right?
Yeah.
And then we began with the calculus, jumping into understanding composite functions because, let's keep it real. I mean, nobody's just going to ask you what is derivative x to the power of 3. Well, that's not a question to be asked, right? But
True.
definitely, it's a learning process. We start from there. But then we have to see where we are getting into. most of the examples will involve not just one function, many functions, right?
Mhm.
So that is where we jump into this topic on composite functions. So, introduction of composite functions to you, how did you find that?
Yeah, so dealing with functions by itself, I found, yes, to start off with, a little bit tricky, but then as you went on, I kind of was getting the hang of it. And then when you went on to composite functions, it's obviously multiple functions where putting, like, let's say g of x into f of x and then doing it like that. And then when it becomes more than two and stuff, it obviously gets tricky. So you have to try and make sure your working is very clear and nice and concisely laid out, because obviously when there are multiple functions involved, it's very easy to make a mistake. So this nice simple flowchart that you've laid out gives you a clear idea of what's actually happening and what you're doing when doing the questions.
And then we actually consolidated your learning with the examples
Mm-hmm.
where it could help you, right? This example is a composite function where you're finding the derivative of nested square roots. Now, this is another very important examination point of a question, right? So
Right.
it introduces you to a good variety of uh, examples, which can help you definitely to do far, far better in any exam for that matter, right?
And also, what I feel is whenever you so let's say with the previous slide, you introduce the concept, composite functions, and then you give like an example like this following from that. But always your examples are like really complicated and tricky, so that when I actually do questions for my book that are on, let's say, composite functions, they're not going to be obviously as tricky as the one you've provided. So I know if I can do your question, then I can obviously do all the ones in my book.
That's so
So
true.
you put it on that like challenging scale.
That makes a difference, I mean, because only then you can score more than 90% marks, closer to 100, right? That's what we expect when we are having help of a professional. That's the kind of idea, right? So, not only that, we actually introduce another component to this particular question, and that is we are not talking about the language of functions itself. We're not giving you values. We're just giving you the function notation and then the solution of the limit, which is in itself is so complicated. But introducing this right in the very beginning is sometimes challenging. But you kind of took it all. That is so great about you. I like that way, right? So more you can take, more I can share with you. That's the whole idea.
Yeah, it's all beneficial at the end of the day, because when I got to like my overview questions where I had so many questions all together, I just felt super confident doing it. Like I didn't like hesitate to do any, because you do this, you put really complicated stuff throughout the thing that I don't really get surprised or scared when I do the main thing.
That's so true. So here is another way we started with a chapter. So when we actually start with increasing, decreasing, I like to actually introduce you to a topic more graphically, so that when you see the graph, you understand what exactly is happening, how the derivative is working, and how are they related. And that really helps us to understand the whole topic, right?
Yeah, because I'm a visual learner. So seeing the graphs is so helpful for me.
Correct. We always had many examples on graphs. And then when we do a topic, we actually end up with extended exam practice. So, what do you have to say about this extended exam practice after every small chapter?
Absolutely love it, because especially when doing these questions, Mr. Kumar always asks me, like, just not to answer it, just to see what my approach is and how I would attempt it. And I find that even just saying it out loud and talking about it is so close to what I would be thinking in the exam, because my approach is obviously what I'm saying. So when I say it to you and then you would be like, no, you obviously maybe I'm a bit off, I'm completely off the charts, or I'm saying something and you can guide me on where I'm going wrong or how to save more time or other alternative approaches. So that's very helpful when it comes to these extended exam practice questions.
That's true. And in this particular question, which was tricky, we did consolidate the learnings which we had done earlier. What do you have to say about this particular example when you came across it?
Oh yeah, so I actually I loved this one. So it took all the previous questions that we went through and it almost like put it all into one question because you've got so many aspects of it. So we see the graphical side of it. You find the derivative, the composite functions as well, and the whole table. That layout is I find it very helpful, as I've said previously. The table layout is nice and clear, and when you want to come back to this question, it's very important to see it like that so you don't make as much mistakes because you can't be losing those 0.5 marks.
That's the truth. Now, many times our questions are very complicated, as you were mentioning, right? So we did take a very difficult question here. The idea of taking difficult questions is to understand the depth of your learning, right? So that means you can really do a very good question in examination, which could challenge many students, right? So here is a very good question based on search and finding its solution and then looking at it graphically also helps you to get a good picture about it, right?
Mm-hmm.
So what do you have to say about this?
Yeah, so critical points was a new term that was introduced to me because in my curriculum it's stationary points. But what I found out was it's better to use the word critical points or critical number because that is where the derivative is zero or it does not exist. Whereas with stationary points, it's just where the derivative is zero.
Yeah, that's so true. Yeah.
So
And you see many of our examples, right? You may have absolute maximum or minimum, even maximum, minimum local at a critical point, which means as you said, that the derivative is not defined, right? So it does not exist. So at those points, like cusp and corner, right? In an absolute function so simple as that, the derivative does not exist at the vertex. How? There is a minimum there, right? The absolute minimum.
Correct.
So if you ignore the critical points and just stick with stationary points, you may not get the right answers, correct?
Yeah, and you might lose marks on those like small things.
Right. And then we also took this rational function. What do you felt about this?
Yeah, so in I think I don't know previous topics when we were doing functions and things, rational functions came up, but I always found them a little tricky in obviously understanding and things, especially graphing them and things like that, because it's obviously a bit of a weird one. But when it came to this and differentiation and seeing how it's actually graphed and things, it gives me a better understanding of the functions itself. So not only am I knowing more about the way the differentiation and that process works, I'm also like consolidating my learning on the rational functions as well. So everything I learned previously, I'm just understanding it more and more as I go forward. Does that make sense?
That is so true. Especially the concept of oblique asymptote, right? So when you're doing rational functions, the concept of oblique asymptote is not very clear to students. And how a function approaches the oblique asymptote is not at all clear, right? So when we do calculus, we can clearly see how the function approaches the oblique asymptote, right? Calculating was easy earlier, but now you can really appreciate it. And that makes a huge difference, right? So when we try to figure out how is it approaching, then you can really sketch a real correct, accurate function. So that was the beauty of this. And then rate of change and optimization questions are like huge, right? So we covered a large variety. Here's one of them. What will you like to say about this?
Yeah, so application questions, you almost do that in all the lectures we do because application questions almost like round off and encompass everything that we've learned, and obviously putting into more word kind of problem questions. I find that quite tricky, but when you pinpoint and like pick out the key things in the question, you see how it links to the topic we're learning and how using those equations or formulas or things would help to answer this question, because application questions are usually so many marks. So usually when I see them in the exam, I'm like skip, but now when I see it, I'm like, okay, I think I can do this. So
in application, I would love to give you all variety. For example, we may give you start with examples: straight line, circle, sphere, cone, pyramid, all kinds of structures, right? So that, how to deal with these situations, correct?
Right.
And how about this? Is this familiar example to you?
Yeah, so this was a question for my book, and I actually got stuck on that. So I sent it to Mr. Kumar, and he replied immediately, which is very good because if you leave it for too long and no one's answering to your questions that you're asking, then that's really annoying when you're trying to move forward because you're going to have that like burden on your head. So yeah, when he responds immediately, it's so easy to understand it and answer the question. And also, what Sir does is when you have a difficulty in a question, I usually send it to him, and he like kind of rounds up a question like similar to that, but not the same question as the one I sent, so that afterwards I understand the concept. I can do my own question, and yeah, usually I obviously get it right because I understood the concepts.
That is so true. So our concept is very simple: just not putting the fish on the plate to teach you fishing, right? That's the whole concept. And as you're very right, I normally don't take up questions from the book and discuss them. But here the idea is that we are just sharing that this is the question which you brought in, and immediately I actually solved it for you, and then send a picture over the WhatsApp so that you don't get stuck and just you move along, right?
Yeah.
And definitely, only one question doesn't really help. And so it is necessary for me to make some more questions which are similar to this, right?
Right.
Where you could get some practice. And that's the whole idea that when I make my own questions, which are very similar, they give you more insight to your learning and how to approach these questions, correct? So
Right.
that was the idea. So I actually, in this particular thing, shared two questions. Here's another one. Do you remember this one?
Oh yes, that was really hard for me. But yeah, after all of that, the layout and everything that you've done, it's done in such a way that honestly anyone can understand it and answer the question. So that I found very useful.
Yeah. So on my YouTube channel, you'll find at least 10 or 12 examples based on similar concept.
Yeah.
Graph is like huge in any examination worldwide, right? So because international GCSE, right, GCSE level, people are all students from all over the world are there. So I've seen many papers. In every paper, there'll be one question where a question will be on this particular topic, right? So
All
it's a very important concept, and therefore my channel, one particular playlist will have so many of them, right? So you should go through them again. Here is another thing is which we call exam review after every chapter. How do
Yeah.
you find these things?
Yeah, these ones, yeah, I found really good. So, with the previous exam questions, it would just be question 1, 2, and 3, and end of. With these ones, because there's part A, B, and C, it's almost like a follow up, and this honestly gets closer to what the exam would provide. Because in the exam, they also do the part A, B, and C. Because doing part A obviously helps with part B and then C. But what I learned actually is that that's not always necessarily the case. Just because you can't do part A doesn't mean you can't do part B. So if you can't do part A, don't ignore the whole question because you can easily gain marks from the other parts. So B and C.
Perfect. That's a key, right? Good you shared that.
Yes. Because I always make the mistakes and I forget. Yeah, because then I realized, I remember in our previous lecture, you said, oh, I could attempt part B even if I didn't know A. And I was like, oh my God, I could have gained marks from that. So yeah.
So don't give up, right? Don't give up. We're fighting
That's
for
the
every
moral.
mark here, right? That's so true. Communication is a great thing. Many times I think that students ignore communication. They may get all the right answers, but even then they don't get full marks, right? Because
Yeah.
point five is lost in so many places because they've just missed out on communicating how they came to the result. For any good exam like GCSE, communication is very important. And therefore, we actually focused on this. So, what do you have to say about this particular slide?
Oh, so I love this slide because when I was doing this, I remember doing this lecture with you, and you had a more complicated version of that last box there. And obviously, the 3 functions on one graph looks really complicated, and it was like label them, which one's the first derivative, which one's the function, which one's the second derivative. And looking at it like that, it was super confusing. But as you've broken it down, it shows me. So what this clearly like shows, even now I can remember it, and this was way back. You can see when it comes to, let's say, second derivative, pinpoint the zeros, find the zeros, look at the point of whether it goes like positive to negative, so that's above the x-axis, below the x-axis, and look for turning points, place the turning points, and obviously when there's a change in concavity, there would be a point of inflection, as we see as it goes straight through the origin. And obviously these small concepts, I've now moved on to so many topics since then, and I can still remember that concept. So it's from that honestly, like this simple graph, you can understand so much from it. So I don't think I'll actually ever forget that. So yeah.
So true, so true. A very simple question to end with, right?
This was the one.
Right. So this actually throws you off, like to figure out which one is the first derivative, which one is the function, which is the second derivative. So complicated. So, but that could be in some very tough examination questions, right? So we have to prepare you for not only GCSE level A, but for any other exam, right? And this course actually is very important for even first-year students in the university, because every university first-year curriculum will include calculus. So that's where it is very, very important, right? To understand or have a better depth of it, so that even in first year of your university, you don't, start, you just sail through. So the whole idea here is not only to do school level examination, but to get prepared for your university and come out with flying colors. So that is what it is. And it was so nice of you, Emmy, to summarize it so beautifully. And I actually loved the whole process of working with you, teaching, guiding, and mentoring you in this particular case. And that was really wonderful.
Yeah, thank you so much. So I honestly couldn't have done it without you. Like, I think just like these very rigid formula-based pattern methods that you learn at school, and they'll just be like simply just memorize. I feel like you introducing all these other concepts to understand it, like either it's visually with the graphs and things, or the flow charts, and all your YouTube channel, like the videos on your channels, breaking each question down. And like you said, the trough questions and things, having so many questions on just maybe that one aspect, it really helps you to understand the concepts in such greater depth. So I couldn't thank you enough. So thank you, sir.
My pleasure. Thank you, Amy. Have a great time, and looking forward to the next unit, which will be vectors.
Yes. Looking forward to that. Thank you so much, sir. Really appreciate it.
All the best. Bye.
Thanks, sir. Bye.